Alright, so now if you have discovery board, STM32F407VG discovery board, then it actually comes with two flavors. One is the older board and now another one is newer one. So you have to check the name of your board first. For example, here is the image of the board. So here you can see that the name is STM32F407VG disk 1. So disk 1 means it's a newer board. And if you don't see this name, okay, so then it's an older board. And also remember that MB997D is a board identification number for the newer STM32F407VG discovery board. And MB997C is for older boards, so you have to know this difference. And on your board, on the right hand side, you see one microcontroller here. So this is the main microcontroller of the board, and this is a microcontroller used for this ST-Link circuitry. So this is what you're seeing here is called as ST-Link circuitry, which is actually in-circuit debugger and programming circuitry. So by this circuitry, you flash the code onto the microcontroller as well as you debug the code which is running on this microcontroller from the host software, okay, like Keel or Eclipse. And this circuitry is called as ST-Link. Okay, so make sure that these two jumpers are connected properly, so otherwise your PC won't detect this ST-Link circuitry. And this ST-Link circuitry comes with a firmware in order to operate properly. And in this product description page, what they say is onboard ST-Link version 2 on this discovery board, that is for old board, okay, and ST-Link V2A for the newer board. So that means there are two versions of this ST-Link. The version number V2A is used in newer boards, okay, and version number V2 is used in older boards. Alright, so now let's explore about this board a little bit, okay. So first let's explore about the discovery board. As I said, this is the ST-Link circuitry and this is your microcontroller board. And for the full features of the board, you have to refer to the user manual, as I said. And remember that this is the main microcontroller and the part number or name of the microcontroller is actually written on this microcontroller itself, so you can have a close look on the microcontroller. And this is a discovery board which has 4 LEDs, okay. So here you can see these are the LEDs, okay. It has 4 LEDs and this is the user button and this is the reset button, and also it has various pins here on the expansion header in order to connect your various other peripherals such as LED and other sensors. And it also comes with one micro USB connector here. We don't use this connector for this course, okay. This is actually used for some USB related experiments, and we connect to the PC through this mini USB cable. So you have to take one mini USB cable and you have to connect that into the mini USB connector over here. And please note that so this board comes with 8 megahertz of external clock, which is very close to the microcontroller here. And this clock is for the ST-Link circuitry. So this is the external clock used by the microcontroller, but by default the microcontroller doesn't use this external clock. So it is there on the board, but it is not used until you write some code in order to switch the clock to the external clock. So the microcontroller will always come with one internal clock that we call as internal RC oscillator, and by default the microcontroller uses its internal RC oscillator. Great. And this board, as I said, it is rich in feature compared to the Nucleo board, and it contains lots of MEMS sensor, and you can get the details about the sensors on the user manual. Now let's take a look into the Nucleo board. So Nucleo board, as I said, it has less features, and important thing about this hardware is it is Arduino compatible. Okay, supports Arduino and STM32F4 connectivity. So you can use some of the Arduino shields onto this hardware, and you don't find any sensors on board. Okay, so it doesn't come with any sensors. And on Nucleo you don't find much LEDs, so only one LED is present. You don't see any sensors, and it also has user button as well as reset button. So, and it doesn't come with onboard external oscillator. Okay, and one major advantage in the case of Nucleo board is this has virtual COM support. Okay, so that means when you connect your Nucleo board to the PC, it will enumerate as the virtual port. Okay, suppose if I open my device manager here you can see my Nucleo board is actually enumerated as COM3 port. Okay, so that means I can talk to the board over the UART by just connecting my Nucleo board to the PC. But that feature is not available in the Discovery board, and for this you have to make some settings. So that is actually mentioned in the user manual of the Discovery board. So here if you go to the Discovery board user manual, if you go to the section ST-Link V2A or V21 VCP configuration, that is virtual COM configuration, the ST-Link V2A, that is a newer board, okay, supports virtual COM port on U2 pin 12 and U2 pin 13, but these pins are not connected to the UART of the STM32F407 microcontroller for embed support. So this is problem, okay, in order to enumerate the virtual COM port support. So that's why they give two solutions here. Okay, one is you use UART to USB dongle from the market. Okay, that means you buy it from the market. Okay, so those are actually very low cost devices. So you can buy one dongle, UART to USB dongle. So if you can just search in these are very low cost dongles you can use to get the virtual COM port support. Okay, or you have to short these wires here. Okay, so that is actually a tedious process, and I suggest you not to do that because you may damage the board. Okay, so that means the virtual COM port support is not directly available, but on the Nucleo it's already available. So that connection, this connection is already exist on the Nucleo. That means I can communicate with this board from my PC over UART without using any external USB to UART converter dongle.